Logarithms. What are they? Exponential functions and their inverses. Consider the function y equals 2 to the exponent x. This function would produce this table of values and this graph. Now, let's take the inverse of the function. This is done by reversing the values of x and y. This will now become x equals 2 to the exponent y. This function would produce this table of values. Notice the x and the y have switched places, and this graph. The blue line represents the exponential function, and the golden colored graph represents the exponential function's inverse. Because each value of the inverse graph gives a unique y value, the inverse is also a function of x. In the inverse function, the y value is the exponent to which the base b must be raised to produce c. We would get x equals b to the exponent y. In the mathematics of functions, however, we are usually preferring to express the y equals coordinate in terms of the x coordinate. Therefore, we came up with a new relationship. We, of course, being the mathematicians and earlier than us, but to restate the relationship as y being the logarithm of x to the base b. And we write that in the form y equals log b x. But we really say it as y equals the logarithm of x to the base b. This function, however, can only be defined for b greater than 0. b cannot equal 1. Now, how do we use logarithmic functions? Why do we need to know this? You already received an introduction to this in Lesson 8 when you were solving for the variable that was unknown. Another function, it can be used to solve a variety of problems such as determining earthquake intensities, the Richter scale, the pH of solutions. If you've all taken chemistry, you know about this now, and measuring sound, decibel relationships. Now, sample problem number 1. Rewrite the equation in logarithmic form. 16 equals 2 to the exponent 4. This can be written in 4 equals the logarithm of 16 to the base 2. Sample problem number 3. Evaluate. The logarithm of 81 to the base 3. Solution. Rewrite in exponential form. 3 to the exponent y is equal to 81. Write with the same base. 3 to the exponent y is 3 to the exponent 4. Set an equation from the exponents. Y is equal to 4. Sample problem number 3. The logarithm of 81 to the base 3. Solution. A second method that we could use to solve this is the change of base rule. What is that, you ask? Rewrite the exponent in the form the logarithm of 81 to the base 3 is equal to the logarithm of 81 divided by the logarithm of 3. Using your calculator, take the logarithm of 81 Divide by the logarithm of 3 and you will get the answer 4. Test your answer to make sure you're correct. 3 to the exponent of 4 is equal to 81. The power law. The power law is written: the logarithm of x to the exponent n to the base b is equal to n times the logarithm of x to the base b. B has to be greater than 0, it cannot be equal to 1, and x must also be greater than 0, and they all can be real numbers. This looks confusing, but let's break it down. Sample problem number 4. Evaluate the logarithm of 9 to the exponent 4 to the base 3. Applying the law, this would mean that the 4, which is your exponent, your n value, comes to the front of the expression. You're left with the logarithm of 9 to the base 3, but 9 can be broken down into 3 squared. If we take a look at the expression, we would know that log 3 with the 3 squared, that's going to equal 2, so we get an answer of 8. Now, let's practice.